our lesson today, you will need your math notebook, you will need your problem pages, and you will need whatever you were using, like your Chromebook, whatever you're going to be doing your calculating on. Today we're going to be working on telling the difference between proportional and non-proportional relationships. So we've been talking about proportional relationships, and that means that there's a relationship between two numbers. So that if I'm getting 2 assignments done per hour, then in 4 hours I should have 8 assignments done. Okay, because every time our number of hours increases by 1, our number of assignments completed should increase by 2. Okay, so a non-proportional relationship would be something like, so let's say I have 1 math assignment, 1 social studies assignment, and 1 grammar assignment. Maybe my grammar assignment takes me 10 minutes, my math assignment takes me 40 minutes, and so basically the number of assignments completed is not the same in each of those situations. So as we complete complete 1 hour of work, we will not always be completing 2 assignments. Okay. Maybe if I was doing only math assignments, maybe I would get 1 assignment done every hour. Okay, so then you would expect as I complete more assignments, one for every hour, I'll complete 1 more assignment. But maybe I also have spelling assignments to complete. Okay, and 1 spelling assignment takes me 20 minutes. Okay, so let's say I have 2 assignments, 1 math assignment and 1 spelling assignment. That's not going to be proportional because as 1 hour passes, I'll have completed 1 assignment. But then after another 20 minutes, after only 20 minutes, I'll have completed a 2nd assignment. So as the number of minutes goes up, yes, the number of assignments is going up, but not at the same rate. Okay, so that rate is going to tell us if a relationship is proportional or not. Let's take a look. Let's get going here and take a look at our first examples. You have been hired by your neighbors to babysit their children on Friday night. You are paid $8 per hour. Complete the table relating your pay to the number of hours you worked. Okay, so $8 per hour. All right, so in 1 hour, per basically means in 1. So that's our ratio right there. Remember, word problem, we're looking for the numbers. We're looking for important pieces of information. Okay, paid $8 per hour. Per hour also includes a 1 because per means in 1. Okay, in 1 hour. And so the question we have to answer says complete the table. Okay, so that's the thing we have to do. We have to complete the table. So if we get paid $8 per hour, $8 in 1 hour, here's our ratio, would be 8 to 1, okay? And so then our rate, remember you divide the first number by the second one. So our rate is $8 per 1 hour. That is not, there we go. $8 per 1 hour, okay? So now, 1 hour worked, how many dollars would that be? Okay. 1 hour worked equals $8, right? That makes sense. Hours worked. If we work 2 hours, in the first hour we made $8, in the second hour we'll make another $8. So that'll be a total of $16. 3 hours worked, 24, another 8. 4 hours worked, another 8 is 32. Now we have 4.5. So for each hour, it's $8. What if we're only working half of an hour? Well, if we're only working half of an hour, then we're only going to make half of the amount of money we made in 1 hour. Okay, so you could figure it out that way by figuring out what is half of 8. Or remember we made an equation for our examples before, and that was where we had 2 variables. So in this situation, we would have hours worked and pay. So H equals P for pay. what do we need to multiply hours worked by to equal the amount of pay? So h times what equals the amount of pay? Well, here it's 8, okay? 8 times h, remember we use the dot. I'll make it nice and large so you can see. H times 8 equals the pay. So the number of hours times 8 is going to equal the number of dollars, okay? So if we, and looking at these, 4 times 8 does equal 32. So now what's 4.5 times 8? And if you don't remember how to put this in there, 4.5, so how do you type 4.5 in a calculator? Okay. Remember what we did last time, where we turned fractions into decimals. All you need to do to turn a fraction into a decimal is do the numerator divided by the denominator. So 1 divided by 2 equals 0.5, but this isn't just 0.5, it's 4 and 1/2. So this will actually be 4.5. So then we can put that into our equation. 4.5 times 8 should give us 36. 36, okay? And if you can see, 1/2 of 8, okay, is 4. So if we would have made $1 or $8 in 1 hour, in half of an hour we would make half of $8. So that would end up being $4. 32, okay, and then another half hour takes us to $36 total, okay? Now we've got 5. You can do it either by jumping up. There are 3 ways you could do this. Okay, add another 8 as we go from 4 to 5. You could add another 4 from 4.5 to 5. Or you could just put 5 in our equation. Either way, or regardless, you should get 40. 6 times 8 gives us 48. And 6.5, they already have that one as a decimal, so we don't have to convert that at all. We can just put 6.5 in there, because 6.5 you can put in a calculator. 6.5 times 8 should give us 48 plus 4, or 52. And there we have completed the chart. And I'm guessing, okay, I haven't even gone down, but based off of our lesson title, I'm guessing it's going to ask us, is this relationship proportional or not? And we know a relationship is proportional or not based on, is there a consistent rate? Okay, is the rate always the same? Was this rate always the same, $8 for every 1 hour? Yes, it was. So even though we used half hours in these two situations, the rate was still the same. Okay, when we worked half an hour, we got half of $8. Okay. So let's scroll, well, let me erase this and then we can scroll down and just take a look. You should have this written in your book by now, or in your lesson notes that you have there. Let's take a look. Based on the table above, is the pay proportional to the hours worked? Okay, we just said yes. And we know because the rate or the ratio of dollars to hours is the same in all of the examples, okay, in all of those situations. That ratio never changed. If that ratio did change, for example, if you got paid $8 an hour for the first 4 hours you work, and then you got paid $6 for each hour after that, then we would not have a proportional relationship, okay? Because this ratio would not be true for all of the number of hours, if that was the case. That was not the case in this example. So this one is a proportional relationship. Then let's go on to our next example here, exercises. All right, I'll erase this, and let's take a look at what they're going to ask us to do. For exercises 1 through 3, determine if y is proportional to x. Justify your answers. We're going to have to explain for each of these exercises if y is proportional to x and y. The table below represents the relationship of the amount of snowfall in inches in 5 counties to the amount of time in hours of a recent winter storm. Okay, so what is going on here? Let's take a look. First of all, what do we need to do for each of these problems? We're going to determine, is y proportional to x? Okay, and each of these groups of numbers is 5 different situations. Okay, 5 different examples in this one table. Well, what does the table tell us? Time and inches. Okay, so in 2 hours, this place got 10 inches of snow. And we know that because it says, represents the relationship of the amount of snowfall in 5 counties. So this is a county, this is a county, this is a county, this is a county, this is a county. So Milwaukee County, okay, Racine County. These are different areas. So in these different areas, they got different amounts of snow, okay, over different amounts of hours. Okay, so we need to tell, is y proportional to x? So is the rate for all of these situations going to be the same? Is the rate between these the same? These, and these. If they all give us the same rate, then it's a proportional relationship. If they give us different rates, even if 4 of them give us the same rate and 1 of them is different, it's not proportional. All the rates have to be the same, okay? And so those rates are going to be comparing the number of inches to the time. It's not these comparing, it's not these comparing, it's these compared with each other, okay? These ones all compared with each other. All right, so how do we figure out if the rates are the same? Well, let's start out by finding the rate of just one of them. All right, so we want to start out by writing these as a ratio. Okay, so I think it would make most sense to write it in saying, in terms of the amount of time. So this is the amount of snow we got per hour, okay? Or we could do the number of hours per inch, but I think the number of inches per hour makes more sense, okay? So I'm going to put that number second in my ratio. So for this one right here, all right, 2 is going to be the second number of my ratio, 10 will be the first. All right, let's write the ratios out for all of these. 12 to 6, 16 to 8, 5 to 2.5, and 14 to 7. All right. Now, how do we go from here to finding the rate? We need to do division. Divide first number by the second hour, and that will tell us the number of inches of snow in 1 hour. All right. So 10 divided by 2. Okay, take out your calculator and do that. Okay. I want you to write the rates on your own. Okay. So 10 divided by 2 should give us 5. Okay, and let's write out what this means. Inches per 1 hour. Next one. 12 divided by 6. 2 inches per 1 hour. Let's do this one. 16 divided by 8. 2 inches per 1 hour. 5 divided by 2.5. 2. 14 divided by 7. 2. Remember, this tells us 2 inches, okay, per hour. 2 inches per 1 hour. And I'll finish this up. Inches per 1 hour. All right, now the question that we need to answer is y proportional to x? So as the number of hours increases in each of these places, could we predict the amount of snow? Okay. Would it be the same in each of these situations? Well, in all 4 of these places, they got 2 inches of snow per 1 hour. But here they got 5 inches of snow in 1 hour. So this is not a proportional relationship because the rate, even though it's the same in all of these, this one means that rate is not the same in all of our examples. So it is not a proportional relationship between the amount of time and the amount of snow. Okay, it changes depending on where you are. So our answer is y proportional to x? No, because the rate of snow to time is not the same in all examples. Now, what if we didn't have this information up here at the top? What if this wasn't part of our problem? And this wasn't? Okay, if they hadn't given us that information, then as far as we know, this is a proportional relationship. Because no matter where you are, in every hour, you're going to get 2 more inches of snow. That is a proportional relationship. However, because this information was part of the problem, it is not proportional. All right, let's take a look at our next example. And so our answer is just saying, is it proportional or not, and why? We do all that work to make sure that we have the right answer, but that is all the answer that you need to write down. The table below shows the relationship between the cost of renting a movie to the number of days the movie is rented. All right, let's do it again. We usually want to put time, okay? If you've noticed, whenever I have hours, I put that as the second number. If I have seconds or minutes or days, I put that as the second number in my ratio. That's because we say things a lot like this per hour, this per day, okay? So we're going to usually, if they give us a unit of time, something that measures time, we'll put that second in our ratio. So let's say dollars in number of days. So second is going to be days in our ratio. So this is going to be 2 to 6, 3 to 9, 8 to 24, and 1 to 3. Now let's do our division. 2 divided by 6 equals 0.33, repeating. 3 divided by 9 equals 0.33, repeating. 8 divided by 24 equals 0.33, repeating. 1 divided by 3 equals 0.33, repeating. What does that mean? That means $0.33 per 1 day. So I'll just put my dollar signs on all of these. Per 1 day. Per 1 day. Per 1 day. Per 1 day. Okay. Okay, so we have that relationship. So is this a proportional relationship? Yes, it is, because it is the same number of dollars for 1 day of renting the movie. No matter what movie you rent, no matter how many days you rent it for, it is always going to be 33 cents for a day, or $1 every 3 days probably. Okay, there we go. That one's done. Now we're cruising through these. It is proportional because the rate is the same in each example. If the rates are not all the same, it is not proportional. Table below shows the relationship between the amount of candy bought in pounds and the total cost of the candy in dollars. Okay, so let's see. Amount of candy in pounds and the cost of dollars. Which one should we put second? Okay. Let's put, you could go either way on this one. So you could make your own choice. If you do it differently from the way that I do it, you might have a slightly different answer, but your answers should match mine in terms of are they proportional or not. So if I have proportional answers, you should have proportional answers too, even if you choose to set yours up the opposite way I do. Okay, I am going to do, let's do dollars first. We'll say dollars per pound. Okay, so dollars per pound. Okay, so 10 to 5, 8 to 4, 12 to 6, 16 to 8, 20 to 10. All right. And let's go ahead and start working through those. Divide them out. Equals 2, 2, 2, 2, 2. Okay, you can do that mentally, but doing it on your calculator. Now, at this point, you probably already know that this is a proportional relationship without having to do any more work. All right? In fact, you could just take these and just do 5 divided by 10, 4 divided by 8, 6 divided by 12, 8 divided by 16, 10 divided by 20. If you keep getting the same answer, you know once you've gotten through all the way through the list, if you always get the same answer, you know what the answer is. Okay? But let's label these. Okay? So this is amount of, we put dollars per pound. Okay? So this means $2 for every 1 pound of candy. $2 per one, and the abbreviation for pound is not BL, is LB, okay? 1, and maybe that'll be confusing, but I'll just write my ones like that. 1 pound per 1 pound per 1 pound per 1 pound per 1 pound. Saying pound made me write a P. 1 pound. Okay. So are these all proportional? Or is this a proportional relationship, the amount of candy to the number of dollars? Yes, because every time I buy 1 more pound of candy, it's going to cost me $2 more. No matter how many pounds I buy, no matter how many dollars I have to spend. Get it? Got it? Good. Next one. And we are almost finished. This is our last example. Randy is planning to drive from New Jersey to Florida. Every time Randy stops for gas, he records the distance he traveled in miles and the total number of gallons used. Assume that the number of miles driven is proportional to the number of gallons consumed in order to complete the table. All right, let's look for our important information. I'm looking for numbers first of all. Okay, I don't see any numbers, so let's look deeper. Planning to drive from New Jersey to Florida. Okay, that doesn't sound important. No, thank you. Every time Randy stops for gas, he records the distance he traveled in miles and the total number of gallons used. Okay, so this chart is telling us each time he stopped for gas, he records the distance and the number of gallons he used. All right, awesome. Okay, now we're done with that piece of information. Figured out what that tells us. Just tells us what he recorded. Assume that the number of miles driven is proportional to the number of gallons consumed in order to complete the table. So to fill in these numbers, we have to know already, is it proportional or not? Because if it's not, then we can't predict what goes in these spaces. Because it's a proportional relationship, we can solve this. Okay? So we're expecting the number of miles driven is proportional to the number of gallons consumed. So the number of gallons he uses is going to be proportional to the distance he travels. Okay? So let's figure this out. How can we fill in these numbers? Well, here, he used up 2 gallons to go 54 miles. Okay? And this is going to be a proportional relationship. So that means every time he travels another 2 miles, he's going to use up another 54 gallons. So, in other words, if I write that out as a ratio, let's say 54 to 2, and divide it out, we can find our unit rate. Okay? Or we could do things a little bit differently, and you might know by now, okay, well, 2 gallons uses 54 miles. I just have to double that, because if my number of gallons doubles, my number of miles doubles, okay? So you could do it that way, or we're going to find our unit rate, okay? So if we divide that out, that equals 27 miles per gallon. 27 miles per 1 gallon. So every time he goes uses one more gallon, he goes another 27 miles. Okay. We could even go so far as to write out our equation. Okay, 27 miles per 1 gallon. So let's say M equals G. okay? So what do we have to multiply one of these numbers by so it equals the other? Well, if it's 27 miles for 1 gallon, then we have to multiply gallons by 27 so it equals the number of miles. Okay, and you can see that here. 2 times 27 equals 54. 27 times G. Okay, so all we need to do then is take the number of gallons, multiply it by 27, and we should have our answer. 2 times 27 does equal 54. 4 times 27, or you could do, well, every 2 gallons. So if he's used up 2 more gallons, he should have gone 54 plus 54. Either way, you should get 108. All right. Let's skip this one for now, and let's work on these. Okay, 10, just use 10 gallons, 10 times 27, or I'm looking here, 8, he's gone 216, so he's using up another 2 gallons to get from 8 to 10, so I should be able to add 54 more miles, so that should be 270. So either way, 10 times 27, or 216 plus 54 give me 270. And the next one, same thing. 2 more gallons equals 54 more miles. So we could add that, or 12 times 27. Should give us a total of 324 miles driven. But what about this blank space right here? Okay. So we've got 108, 189, okay. So let's figure out what number goes here. It might look like, well, 6, because this goes 2, 4, well, we don't know what's there yet, 8, 10, 12. It looks like that's a pattern, right? Let's try using 6 in this example, okay? So what if it's 6? That means that 6 times 27 has to equal this number of miles. Is 6 times 27 189? Let me do that one on my calculator really quickly, but I think it's going to be a no. 6 times 27 is actually 162. So that's not correct, because when I put 6 in here, I get 162. This number is not 162, so that can't be correct. All right. So what else could we try? It's not 6. We could either try 5 or 7. Okay. If 6 was 162, it's more than 162 miles that he went. So I would guess that the number of gallons used is more than 6. So what if we just try 7? 7 times 27. 7 times 27 equals 189. Okay, so if the number of miles is 189, then the number of gallons has to be 7. It's the only way for this equation to work out. So I don't actually want 6 in here, I want 7. Okay. And so that's one way that going too fast and just looking at these numbers might cause some mistakes. Okay, so if you can make this equation, okay, or use that rate here, okay, 27 miles for 1 gallon, you could just keep adding 27 to 108 until you've hit that. And remember how many times, okay, how many more gallons, every time you add 27 miles, you have to add 1 gallon. So if we did 108 plus 27, okay, not there yet, plus 27, not there yet, plus 27, now we're there. I added 27 3 times, which means 3 gallons of gas. Okay, so there you are. We have gotten our answers. And so our thing above said that we only needed to follow those instructions for exercises 1 through 6. So let's see, we just needed to fill in the table. We have done that. Okay, so we finished that problem. And that should be the end of our lesson. Okay, so hopefully at this point, you know that you can tell the difference between a proportional and a non-proportional relationship. Okay, and you do that by comparing the rate. Okay, or it could be the unit rate. We haven't used the unit rate very much because it gives us less information than the actual rate. Okay, remember the unit rate is that rate without the extra numbers and words. Okay, so I prefer the actual rate to use that instead of the unit rate. And so we just compare those for our different examples. If the rates match up in all our examples, we have a proportional relationship. If the rates don't match up, if it's not consistent and staying the same, it is a non-proportional relationship. You may go ahead and head to your math assignment where you will need to complete those problems that are listed on Google Classroom. All right. Let me know if you have any questions at all. I will be happy to help.